at Indeed that how we migrated or how we are planning to migrate tons of clusters which are on homegrown platform to MongoDB Atlas. But before that, who we are, and as you know, probably might, Indeed is a top resource for online searching online jobs. And we are a leader in HR tech space. But most important of all, we help people get jobs. Yeah. Um, so a few years ago, we made an ambitious goal of migrating every single piece of infrastructure that we have today to from on-prem to cloud, both for job seekers as well as for employers. And more recently, we made a goal that we want to migrate every single MongoDB clusters that we have to something on like a service provider like Atlas to enable full autonomy and self-service for our engineering organization. So where are we on these migrations? I did like to think of this as in like an everything bagel. I love everything bagels. To show our the migrations, all the seeds that are on this bagel, wonderful bagel. They're like clusters all scattered around. So just remember this: like we are somewhere in there. Now I would tell about our homegrown platform, which we internally call something called Quartermaster. There is a history about like what Quartermaster is back in the days at Army, but I'm not gonna talk about Quartermaster right now. So we have been successfully using an internally developed system for years. It's been very successful for our engineers since 2017. It's like a self-service system that we use for provisioning MongoDB clusters. So far, we provisioned like over 1,000 clusters in QA production across 6 AWS regions, as well as the private data centers of Indeed. It serves users. It's just like a self-service, and along the way, we wrote like hundreds of wiki pages with screenshots on procedures, explaining specific like tasks and troubleshooting, enabling self-service, and much more. But with such large systems, there are always some challenges. And I wanted to summarize all of these challenges in one single, like a small slide. First of all, we had to keep up with the MongoDB versions, which are not fun. Like if you have to maintain those binaries and download those binaries online and then install and push it out via Git repo and Puppet, and make it available for our engineers. Every single time there is a release come, okay, not just the major versions, but also the minor versions that we have to keep track of. Then we had to provision and maintain the underlying EC2 instances. We are on AWS, by the way, but not on Atlas yet, right? So we had to provision and maintain those EC2 instances while juggling the cost optimizations and batching. We depended on Mongo dump and Mongo restore, which probably a lot of you have known this utility that Mongo has, but for some reason, I don't know why, they decided to deprecate. Like for sharded clusters, it became a risk when we could not make any consistent backup restores, because from 4.2 onwards, they kind of deprecated this utility, which kind of sucks, but they all wanted us to move to Atlas, I guess, so. So why Atlas for Indeed, right? Well, can't emphasize enough. We wanted full autonomy and self-service for our development teams. Atlas is a cloud-native managed service that would overcome people cost in developing and supporting our control plane. I think control plane, whatever. And the Quartermaster is our control plane. It's a pain. There were tools from MongoDB like live migration. I think push and pull. Sometimes I get confused between the two, but with experiments, it does seem to work. and as an org, since we have chosen Terraform, I don't know how many of you use IAC, Terraform. Like, it's super good, but it's terrible at the same time. But we are stuck with Terraform, so we're gonna make our transition into Atlas with Terraform. And we have decided this to be our standard, and it blends. And Mongo Atlas supports Terraform pretty well. Melissa Plunkett is somewhere right here. If anyone has any issues with Terraform, you can grab her. And of course, when I talk about migration strategy, there is always automation involved. So with the strategy, we first identified our goals and as well as our non-goals. Like, people like to talk about goals, like we wanna, this is our goal for migration, but most importantly, we also talk about non-goals here because it is important enough to identify both in order to put your processes in perspective. So for the goals, we wanted to migrate both sharded and non-sharded clusters pretty efficiently with as much automation as possible. We wanted self-service, number one priority for us, and self-service deployments and faster migration. But for our non-goals, it was not the goal as to immediately deprecate our quartermaster system because it is still in use, but it will still happen. It will go away, but that's not the goal. And we are not discouraging the use of AWS directly because under the hood, Atlas still uses AWS, but that's not our goal to directly not use AWS. We are still here. Next, we listed all the components of this migration, all the tools that we have around that we are gonna use, like Terraform, CM is like Cloud Manager, Vault, then there is Argo Workflow, which we're gonna talk about a little bit here. All the live migration components that Atlas provides, there is a ton of Atlas enabled live migration components that you would actually use when do the migration. It's a smooth process if you can knock out all at once, but I'll talk about some challenges there too. And of course, there are migration agents involved into this migration. And then there is the destination Atlas. Then we prepared a workflow laying out these components and deployment, and test each component individually, and then build a process that manually triggers each component, and so as to we can gain confidence. And finally, the automation, the most important part and the most fun. On Atlas, let's talk about some key points to remember when setting up Atlas when you are not directly using the UI, but you are interacting with the UI through your API, through the Atlas API. And what are the most important things that I like to talk really quickly is first, we create the API keys per project and per environment. We have two, like QA and prod. We just short circuit stage. And with the determined role and the required API access list entries, why I talk about access list entries is because with the Atlas API, with the API keys, you need to have certain IPs that you are going to provision into your Atlas. You need to put those IPs into the Atlas enable list. For our case, those IPs those source IPs are from our Terraform enterprise servers. If this is going to be too technical for any of you guys or too boring, just let me know. I'll just run away. But we created, it's going to be very boring. And I'm warning you, this is going to be really, really boring and not fun. We created project and setup networking, which use regional private link endpoints. Now, I heard people talking about VPC peering a lot. Nobody talks about private link endpoints because they are really, 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 really fun. And and to because our security do not like no VPC peering. We are super secure. We are super private. We don't want Mongo to pick into our network. Mongo is shady sometimes. They can do some real damage. But no, don't take it seriously. They are not that bad. Then we created teams and invited members on the team to that project. We did this to ensure members are tied to the specific team only and that have access to their own project and isolate teams with the Atlas org. I think that was a little too long, but you don't need to understand all of these things, Create the Atlas project. Finally, we could then create the cluster in the project. That's the last stage, and then that will be the target for our respective service. Oh, yeah. And then the fun part, automate everything as quickly as you can. Otherwise, you can run the risk of having lots of money just expire in your Atlas account. If the contract expires, it's kind of scary. But yeah, we'll have to do this very quickly. Otherwise, we'll lose a lot of money to Mongo. The migration workflow, which I call a journey, it's been really a long journey so far, but we just begun, it seems, and then we are hopeful we'll finish it soon. With the help of the automated platform, yeah, that is going to be really tricky to migrate all this. That is ready to embark upon this journey. What is this? Atlas live migration. Oh, this is the live migration push. Yeah, okay. It's a feature to accomplish the goal of migration. Yeah, well, so broadly speaking, the journey encompasses all this. Like I have just put it into one shot because I was instructed not to put too much content on the slides. The slides are already confusing a lot of people. So first, like link your Cloud Manager project to Atlas is like a one-time step you have to go through. Then you provision and configure the migration agent. That is the host, and then you initiate the live migration. But for that, you have to like kind of make sure the Cloud Manager is kind of a in-between agent that would detect your on-prem clusters, and that's kind of a jump box, kind of you can say, like that helps between your on-prem and your Atlas. And finally, cutover. Once cutover is done, cutover is like a divorce between the source and the target. It's like I'm no longer married to you. I'm no longer going to send any more data to you. We are done. So once the target is synced, that's like cutover. I don't know who invented cutover as a term in Mongo, but it's a little sarcastic. Some learnings. Okay, this is going to be really fun, guys. Some learnings along the way. So for the migration agent, you provision enough resources in terms of CPU, whatnot, because you can use the same migration host for multiple different types of migrations, and large enough disk for your oplog. Ensure that the live migration host IP has access to the Atlas project. I think we touched base a little bit on that. And then the authentication mechanism has to be one of these SCRM, the challenge response 1 or 256 authentication mechanism has to be enabled. Otherwise, it doesn't recognize your source clusters for some reason. Ensure the source and target. Yeah, so this initially when I first read this, like, oh, why is Atlas not smart enough to detect the source? Like, why I have to make the versions like why I have to have the same versions on the source as well as on the target? Why I have to have the same number of shards on the source as well as on target? So because if the source and target don't match, as of now, I think Atlas does not know how to proceed with the migrations, it will tell you that this is not going to be compatible. So, and by the way, it has to be a replica set if you are migrating a replica set, and if you are migrating a sharded cluster, it has to be a sharded cluster on the destination that you will create, right? So, another thing I learned is like sometimes our migrations would run, and there is kind of a some kind of a backup that will run that would kick on the sharded cluster balancer, which is which will break the live migration. So we learned the hard way that we need to stop we need to make sure that no other external backups or any process that would kick on the migration, the balancer. But yeah, Atlas live migration process itself, when it does a sharded migration, it will take care of the balancer on its own. And finally, plan a small downtime for your application. A lot of applications cannot afford a downtime, so we'll have to plan around that when a cutover happens, when the breakup happens, so as to reduce the cutover time. Dual writes are generally better if you ever want to go back to your source cluster for writing. If you decide that no, Atlas is not working for me, I want to switch back, then you better have dual writes. Fortunately for us, our Atlas team is so great that we are so confident we may even skip dual writes, but we are not there yet. There is more effort involved in setting up this dual write thing. So, yeah. I did want to highlight some major challenges that we faced along the way. There are a ton, but I could only summarize because I was only given like 20 minutes. So, I talked about a little bit on the private link endpoints. AWS, some of the AWS folks, if you are here, you have a limit of like 100. Only 100. AWS caps it at we cannot have more than 100 private link endpoints for a single VPC. So since we use a shared VPC kind of a thing per environment, we quickly hit that limit. So in the early stages, so we requested AWS, and AWS did not want to lose us as a customer. So they quickly raised that limit to on the request 400. So it's doable, AWS. So it's just that they don't allow you. Those are limits that you will hit at what point you will first not know what to do, and then you will let's talk to AWS and see if they can have some insight into it. And pretty sure, yeah, they were like, yeah, you can talk to us and we can raise your limits. So yeah, we were able to get that limit bumped up to 400 endpoints per VPC, but we soon realized that that's still not going to be enough. So we floated an idea of satellite VPCs. So satellite VPCs is like more VPCs around the shared VPC that each will now take 400 endpoints. Then we have a limit of addressable targets per private link to Atlas limits the number of members if you are migrating a cluster to like 50 by default, meaning that you cannot have more than 50 members, by the way. So if you are really doing large migrations, you will need to work with Atlas folks. They are really nice. The back support guys, they will like, yeah, we will increase your limits, kind of thing. So. But again, they cannot go beyond 100 because AWS does not allow Atlas to go beyond 100. And for Azure, folks, I wish we were in Azure because we could now have 150 limits on Azure. So this is AWS specific. AWS, you guys need to improve. Yeah. So, so we reached to Mongo support, who raised our limit to 100 from 50. In a sharded cluster, starting 5.0, Atlas was kind enough to improve their topology, or in such that they would now allow more than 100 members, but restrict the number of Mongo S instances to 100, because Mongo S is where your clients will connect to. So again, Mongo S cannot exceed 100. But because how Atlas is designed, Atlas attaches one MongoS to one member of your cluster, each secondary. So you can now have more than 100 members, but they will somehow do some magic to limit your Mongo assist 100. Oh yeah, this is fun one. We faced a limit of 24 shards, okay, because we tried to migrate a 36 shard cluster, and it was like, no, Atlas cannot take that. So we went back to MongoDB support, and of course, MongoDB does not want to lose us either. So they generously raised this limit to 50. This is fun. Cross-region network permissions or multi-region nodes for a project to 40. That's the default. This is gonna bite a little bit hard if this is not lifted, but there is a limit basically at 240. You cannot have more than 240 if you are having a giant cross-region network cluster. Then the number of total IPs plus the members cannot exceed 240. These are in the fine prints of Atlas. If anyone wants to, migrate to Atlas, read this fine prints. I mean, it's not really fine print, but it's in the documentation. It's really fun, but it's good to know all these limits. Fun challenges. So yeah, Atlas support would help us raise this limit to 200-ish, since we didn't add several IP access list to because we use private link endpoints, so we don't need any specific IPs other than the migration agent host IP to the enable list. So like we can get up to 200-ish for the cross-region network permission. So last but not the least, here is a very brief overview of our automation on the migration, which we call like Argo. Our goal really for automating the entire process is this, one click. But that's easier said than done. So here comes Argo, and that there is a link. I don't know if the link is displayed. Probably no one in the room knows Argo, but it's a tool we chose to kind of do help our automation. It's an open source container native workflow engine for orchestrating parallel jobs on Kubernetes, with the workflow implemented as Kubernetes CRD or custom resource definition, modular deployment style workflow with reusable components. That means like if you have a workflow designed for replica set, you can use the same workflow and modify a little bit to do your sharded cluster migration. And under the hood uses Atlas CLI and Cloud Manager administrative APIs. Here are the docs. And this is like the final slide. I really want to quickly go through an example of a migration workflow like pictured here. So the arrow in here, each green check is like a completed step in migration, starting from like creating that where you see that arrow is like creating the automation user on the source cluster, on the top to a successful live migration into the target cluster, which is the step marked by the arrow at the bottom. And if any of the steps fail, then Argo would tell us that, hey, your step, this is all green, by the way. Like I have seen lots of reds and errors in this, but I did not take any of those here because for the presentation doesn't look good, So I selected one with all green checks, Argo makes it easier to click the fail step, and we can view not only the failure message, but also the source code that is responsible for the failure, which is kind of cool. You can just click and see, oh, this code failed, and this is the source that is responsible. It gives you a nice error. So all things given, we are hopeful that our all these 1,000+ migrations would be showing like a green check in no time, hopefully. And that's when we call, we made it. Everything everywhere centralized. I every day I see the picture of this bagel and I want to get there. I want to get there. So it's inspirational. But that's it. Like, I won't take more of your time. Questions?
Any questions from Anand?
I'm on time.
Yeah, I was just wondering where exactly in this process you guys are. Where on the bagel are you sitting at this point?
Oh yeah, so I'm lost there too. We are beginning migrations, but we have barely started because all these challenges that I showed, those are real challenges, and we are still overcoming some of those. But with the automation, like in this quarter itself, we are planning to migrate like 200 to 300 clusters in this, and in the coming quarter, like probably, hopefully, I'm hoping that we will be done with 700 to 800 clusters. But the automation is the key, like how this works on a large scale, because you can deploy multiple migration agents. That's what the automation is going to do for us. And you can then run, once the flow is like, it's already tested. We haven't tested in parallel, but we have the necessary resources in Kubernetes to like spin up migration agent. And then once this design is already implemented and published, engineers are just going to use the documentation that we have on a step-by-step basis, and they can just run this workflow that you are seeing here on Argo. And it's basically currently an MR, like you have to push an MR to a system, and then on the UI, they can click on the UI and they can actually run that workflow once the MR is merged. So hopefully, fingers crossed, but we will see those green checks as much as we can. Otherwise, if we're not seeing those many green checks, then Atlas folks are in trouble, and some of my team is in trouble. So.
I had a different question, not quite on the migration, but on the automation in Atlas. Are you planning to have the users create their own cluster in Atlas UI, or are you going to automate that some way?
Yeah, we already automated. So there is we built a Terraform module, and engineering folks are using the Terraform module to spin up their own clusters, whether it's like replica set, sharded, geo-sharded. They can spin up their clusters, but they have to make sure it's like 4.2, because we are on the source, we are on 4.2. So for migrations, it has to match the versions, right? You cannot provision 5.0 yet. So once they are provisioned a cluster, then they can use automation to do the migration. But if they are not using any migration, if they are gonna like a fresh service, fresh application, then we just say that go with 5.0. 6.0 we are not trusting as yet, because as an Indeed, we always did not want to have the most most advanced technology. We are always kind of trailing a little behind, if I would, because we want to see lots of bug fixes before we actually implement 6.0. But we will get there.
Manan, will you be available for questions afterwards?
Absolutely.
Awesome. Well, with that, let's give an awesome round of applause to Manan for a great talk. Thank you.